Calculates. Today we're going to look at optimization problems. Yippee! Word problems that calculus allows us to solve easier. So the reality is you've probably solved problems like these before in perhaps Algebra 2 and Pre-Calculus, but now we will be able to use some calculus strategies perhaps to get to the answers a little quicker. So of course, the one thing that I personally like is drawing a picture because the picture tells me a lot of stuff. So on this first one, when I see that it's a rectangle, basically a rectangular storage container, then I'm going to draw myself a beautiful rectangular storage container. Oh, look who's here, calculus, wanting to do optimization problems. So they're talking about volume, and I know that in order to find volume, I have to do length times width times height. So I'll get that formula written out. And at the same time, I know that the volume happens to be 10. So I'm not exactly sure how I'll be using that, but that is good information to have written down. Okay, so now I come to some interesting information about the length and base, or excuse me, length and width. And so it tells me the length is twice the width. So now I know that L equals, remember that is your equals, and then 2W. So I just wrote an equation that relates length and width. So on the next piece, part B, they want an equation that relates width and height. So of course I know that volume equals LWH, which means now I have a substitute for L, and I also have a substitute for volume. So now I'm plugging in the 10, calculus cannot be on the table, equals 2W, that's the L substitution, times W times H. And I can simplify this so that I have H by itself if I want, and it'll look like this. So make sure you can follow all of my work all the way through here. And so then in part C, when it wants volume in terms of width and height, it really just means I want my equation without L in it. So really, I'm back to working off of LWH. And remember, in place of L, I was putting 2W from part A. And so volume, in terms of width and height only, is 2W squared H. It's almost like I was backtracking on this particular equation. So on this next problem, I already drew my drinking cup. Perhaps you've seen these at the fair. That's where I've seen them. The Sparklets people are usually giving the water out for free, and they use these little cone-shaped cups. So I drew my cup, and since they're talking about 27 cubic centimeters of water, I'm pretty sure that's volume. So I know the volume formula for a cone is 1/3 pi r squared h. I've drawn in my radius over here and my height. And so I'm supposed to find an equation that relates the height and the radius. But of course, from this piece of information up here, I know that the volume is 27. So I can substitute that in, and ooh, look at that. I'm going to have only R and H left as variables. So let's get the H by itself. I could get R by itself, but let's get H by itself. So of course I'll do some math magic. Pause and see if you can get H by itself. Did you get it? Did you get it? Of course, we could have also solved for R or R squared, either one, and it would look slightly different. So as long as I have it down to just R's and H's, because it wants to relate height and radius, I was good.